Hello everyone, I am Bruce and I am based in Shanghai City from China. And I am working in RTOS as the senior software engineer. And now I'm focused on the RTOS Smart OS development. So today it's my honor to have this opportunity to share the RTOS Smart OS. So let me introduce the RTOS Smart briefly. The RTOS Smart is a high-performance microkernel operating system for real-time applications. And the purpose of RTOS Smart is to realize the best balance about the real-time cost, security, startup speed, and so on. Also, RTOS Smart is open source. The code is opening on RTOS GitHub. With the development of edge computing, more and more IoT device data will be collected at the edge part and sent to the cloud. And then the cloud or server will do the data processing and data analysis, then select the result to the edge device. But on the other hand, the AI is implemented from the PC servers into the embedded devices gradually. For example, currently, the edge device can do the face detection and face recognition locally. All those applications and requirements ask a real-time, lightweight operating system. So our R&D team develops the RTOS Smart and provide a more competitive software platform for different industries. As you know, the RTOS Smart is a micro-kernel operating system which is developed based on the RTOS. And the RTOS Smart is aimed to run on NPU processor with memory management unit. The RTOS Smart has some nice features as below. First of all, it is small but fast and safe. It supports UP SMP processor for both 32-bit and 64-bit chips, such as ARM Cortex-A series chips, the MIPS chips, RISC-V chips with MMU, and so on. For example, for the ARM Cortex-A series, the RTOS Smart can be run on QEMU simulator. It also can be run on Raspberry Pi. Secondly, the RTOS Smart boot faster and low power with the DRAM hardware platform, enables MMU applications with separate address space to provide a more secure mechanism for using memory. So, in other words, the RTOS Smart is more safe. Compared with the Linux, it occupied few resources, better in real time, and more secure. At the same time, the RTOS Smart full compile with the POSIX environment, easier to port Linux apps, the C++ apps. As displayed the basic architecture of RTOS Smart, you can see the RTOS Smart includes two modes. One is the kernel mode, another is the user mode. For the kernel mode, the kernel only retains the basic functions such as the process management, thread management, address management, and so on. So the kernel is very small in size, less than 500 kilobytes. And for the user mode, the application part, the common operating system services can be separated and placed in the user mode. For example, you can place the network protocol stack, file system, the device drivers into the user space, and each application processor has a separate address space, so the apps can be operated and upgraded independently. For the API part, the RT-Thread Smart is also compatible with the existing ecosystem of RT-Thread for both kernel mode and user mode. The RT-Thread Smart pays great attention to security and safety. As you know, the whole system is divided into kernel mode and user mode. For example, in the 32-bit Cortex-A7 core, the high 1 GB space can be used for kernel mode, and the low 3 GB space is for user mode. And the kernel can even join with the static memory allocation mode. So the RT-Thread Smart is more secure and safe. RT-Thread Smart can provide the variety of system services in the user mode. For example, for the file system, the user mode can use the FAT file system, the YAFFS file system, so on. For network protocol stack, the user mode can use the low IP, provides a complete BSP socket API and supports TCP/IP version 4 and version 6 dual stack. For the GUI display, the user mode can use the Proxima UI and provide the modern UI system and JavaScript programming includes a majority of the common use controllers, animations, and available for customizations with all kinds of cool effects, as well as the translucence alpha composite and so on. Compositing and so on. Also, it supports the GUI hardware acceleration run integrated with a GPU. By the way, the Proxima UI is not the open source. It's commercial only. The IPC. The IPC message is very important in microkernel. The RT-Thread Smart uses the channel and shared memory mode. When do the message transmission, only use message handler to communicate between processes, and the message is very short, so the message transmission is very fast. And one need to transfer the data, you will use the shared memory mode, so that the data transmission is more efficient. For example, as displayed in the demo of ping-pong message delivery, the ping-pong used the channel to share the message and use the shared memory to transfer the data. The RT-Thread Smart is compatible with PSE53 in use case, including support process with the fork, bfork, and Piper system call, complete network support, standard socket abstract, and supports Unix sockets, netlinks, and so on, and support the POSIX threads, and so on. The RT-Thread Smart also supports complete C++ standard including the C++11 standards with the parallel programming and powerful syntax. Currently, RTOS Smart supports many GMU apps with complete POSIX API and C++ support. First of all, the RTOS Smart supports many ways to build GMU apps, such as MicroKernel, configure make, CMake, and so on. Secondly, more and more GMU apps can run on the RTOS Smart. It means one build file only needed to set some environment variable and without any code modification. For example, you can run the OpenSSL, SDL, SQLite, BGBox, and GMU libraries on RTOS Smart. The RTOS Smart is the next generation architecture of RTOS, and it supports the existing ecosystem from RTOS very well. For the RTOS API, the user mode also fully supports the traditional RTOS API, such as RTOS Create, Startup, RTMutex Create, RTMalloc, and so on. And for the build script, the RTOS Smart can continue to use the existing software environment from RTOS. For example, the RTOS Smart can use the menu configure tool to configure the system on demand and continue to use the sconce kconfigure sconce script. It means it's also easy to integrate RTOS online packages as well. For the RTOS online package, there are more than 300 of the existing software packages can be also used on the RTOS Smart. For example, the AI Kit, WebNet, WebConnect, MQTT Connect, and so on. For the development environment, the user can use the VS Code editor to develop user mode apps on RTOS Smart. For example, edit code developed with remote SSH Linux server will be also debugged with VS Code later. And the RTOS Smart can be developed in both Windows and Linux, but it should be better to use the Linux for development because it's easier to port Linux applications and debug the GMU apps in Linux environment and reuse the existing build script directly. The user also can debug user mode apps at the source level by the GDB. It's the same that transport a GDB stub in the kernel part. So you can perform the soft debugging without detect hardware device. And the debugging way, the user can use the UART and network mode. And what's more, according to the chip type, it can support hardware breakpoint and watch point for debugging. It supports the debugging mode by attaching the PID while the process is running. So, what's the difference between the RTOS and Smart? From the application part, it's hard to feel the difference because both of them are using the same RTOS API, and both of them can perform the hardware real-time scheduler based on the priority and preemptive, and can use the same communication API and multi-thread synchronization. but it's different in the following 2 points. Point 1. In the RT-Thread Smart, for the RT-Thread Create API, the stack size parameter is referred to the size of the user space stack, and the kernel thread stack is maintained by the kernel itself. And point 2, for the RTMV init, RTMQ init APIs, the provided pool space on user space will be invalid and will be specified by the kernel system. And from the driver layer, there are also some differences. Since the system is running on mature address, the physical address will no longer work and need to convert the physical address into a virtual address by the RTIOR map function. So this is totally different with the RT-Thread RTOS, because the RT-Thread RTOS uses the physical address. As you know, the RT-Thread Smart is a micro-kernel operating system, but it should be said that it's a hybrid micro-kernel architecture. The kernel runs on the virtual address, and the peripheral address needs to be accessed with a mapped virtual address. System services such as file system, network protocol stack can run in the user mode. But if one need to balance the safety and the performance, you can move the file system and network protocol stack back into the kernel. Then it will be similar with the RT-Thread RTOS. Some system services can be placed into the user mode space and use the IPC message for communication through a simple proxy approach in the kernel part. An RT-Thread Smart provides a message mechanism for channel and sharing memory. It can be used to share the message between the user space applications and system service, and also can be used between different processes. So, in summary, for the application cases, the RT-Thread Smart can be used in a wide range of applications. For example, the products in security, such as IP camera, gateway, industrial control, onboard device, and consumer electronics, and so on. So, okay, that's all. Thanks for your time. Thanks a lot for your attention. Thank you very much, and have a nice day. Bye.